Hello everyone, how are we doing today? I'm doing pretty good. When I'm doing this, it's a little chilly though, but that's all right. Spring, it'll get warm. All right, we're gonna start talking about 8.2, arithmetic sequence, and then it says impartial sums. We're only gonna, the first video is arithmetic sequence only. We'll deal with the sums afterwards, and it is called arithmetic, not arithmetic, for this, the name of it. There's two types of sequences we're going to look at dealing with these. The first section we dealt with sequence and series, or sums, and we're going to look at two types. One is arithmetic, and one is geometric. To be honest, both of these are kind of the sequences, or what you used to call years and years ago, number patterns, that you're familiar with. In other words, we're doing something to the previous term to get to the next one. In arithmetic, you're adding or subtracting. It can be either or. Typically, we think of it in terms of addition. If it is a subtraction, we add a negative. Okay, we think of it as a negative number then. And then geometric is the other one, is multiplying or dividing. And again, we'll think of it in terms of multiplication. If it is division, it'll be multiplying of a fraction. Okay, but we'll get to that. And actually, geometric goes faster than arithmetic because once we go through this, it makes a little more sense. Okay, all right, so what is arithmetic? It's a sequence where the difference between consecutive terms is the same. Okay, the difference between consecutive terms is the same. Something, simple sequence like that we've looked at a couple times here in terms of things like, 2, 4, 6, 8. That would be arithmetic. What am I adding? What's the difference between each of those terms? Well, I'm adding 2 each time. Well, that number that we add is called the common difference. And we, nothing too grand here. We use the letter D to represent the common difference, okay? And we find that common difference by taking and subtracting the two terms that are next to it. So, we could say, and we go 4 minus 2, oh, that's 2. Okay, and you could have also done, 8 minus 6, and you get 2. It should be the same throughout if it's arithmetic. And that's one of the things we will look at later is checking to see if something is arithmetic or geometric. You do have to kind of check a couple to see if that common difference is the same. Okay, all right, so first kind of examples here, basic examples, is just finding that common difference. All right, what's the common difference on number 1? Well, I'll do this one here. So, to find D, what we're doing is we just take two terms and we subtract them. So 8 minus 5 is 3. Now, you always take the higher term, right? This is A1. This is the first term. This is the second term. So you take the second minus the first. We could have done any two. If you look, that 3 is in all of them, right? 14 minus 11. It's usually pretty easy. Right? So maybe take a second, pause this, and why don't you try to do 2 and 3? All right, so in this case, when we go to do that, we're going to go 5 minus 9. You got to be careful here. So this is negative 4. All right, so my D in that case is negative 4. And notice the sequence is getting smaller. So if the numbers are getting smaller, you are actually subtracting, but we say we add a negative. So we're going to keep it as the D in this case is negative 4. All right, now number 3 is a little trickier because of the fraction. Oh no, but you can see the numbers. Hopefully you can see the numbers are getting bigger because this is 1 and this is more than 1, that's more than 1, and they're getting bigger, so we're adding something. So a little bit of fractional work. That's minus 1. Well, 1 as a fraction is 6 over 6, so the D is 1/6. Okay, and you can kind of test that out and see if it works. If I take and I add 1/6 to 7/6, I get 8/6, which reduces to 4/3. Okay, all right. Well, that's great, and that we have that. But what we're going to do is we're going to kind of develop a little formula here, an nth term formula that works for every arithmetic. And so I want to show you where it comes from instead of me just giving you the formula. Okay, so we're going to start here. We always have our first term, right? Well, to get the second term, let's see if this makes sense. I'm going to take the first term and I add the D, whatever the D is. In the last problem, the first problem in the last page, it was a 3. So I would add 3. All right, so that's what the second term would look like. Makes sense. Third term, I would take the second term and I would add D. Right? Okay. Well, let's think about that though. We just said the second term is A sub 1 plus D. right? It's that. And then we have this other d. So this is this, okay? Well, let's simplify that a little bit. That's a sub 1 plus 2d. Okay, now we're looking for a pattern here. So let's go to the fourth term. Well, that would be, I would take the third, whatever it was, and I'd add a d to it. But we just said the third is this. So a sub 1 plus 2d plus another d, because that's that. And so this gives me a sub 1 plus 3d. Are you seeing a pattern? Well, let's try one more then. A sub 5 would be a4 plus d, but we just said a4 is that, so a1 plus 3d plus another d is a sub 1 plus 4d. All right, so for the pattern, what I want you to look at is this 5, that number, this 4, that number, this 3, that number, and even this one works, this 2, and the number in front of that would be a 1. What do you notice in relationship to them? It's always one less, right? So if I had an nth term, it would be a sub 1 plus, well, this is always one less. How would we write one less? N minus 1 times the d. That is our nth term formula. Okay? So it's a pretty simple formula to use. Now, we will do a little algebra and distribute and do some stuff here to make the formula more usable. Okay? All right, so I'm going to go back to those same 3 problems, and let's write down here what we had on it. So you could go back if you want, just the ones we wrote. You don't have to do this again. What did we have here? We had d is 3, we had d is -4, and then we had d is 1/6. Okay, so now we're going to use that formula. I'm going to write it up here. a1 plus n minus 1d. We have everything we need to write the formula. So if I look at number 1, a sub n, well, what's my first term? Well, it's right there. 5 plus n minus 1 times 3. Now, I would like you to do a little distribution here and simplify with these problems as well. So this is 5 plus 3n minus 3. So my a sub n is 3n plus 2. Okay, now one of the reasons we get this nth term, and you're going to see this in the next example or the next page, is now that I have an nth term, I can come up with any term. If I want the 10th term of this sequence in number 1, I just go 3 times 10 plus 2, so it would be 32. Okay. So number 2, same thing. Okay, so we're going to say, I'm going to say a sub n is the first term. Well, that's 9 in this case, plus n minus 1 times -4. Okay, now we want to distribute. So what do we get there? We get 9, and we'll say minus 4n plus 4. So a sub n is -4n plus 13. Okay, and so that's my answer there. 3 is a little tricky just because of the fraction, but it doesn't change it, okay? So a sub n, first term is 1, plus n minus 1 times the d of 1/6. Now, when I distribute this, I'm going to get 1 plus 1/6 n minus 1/6. Okay, well, a little bit of work here. So common denominators here, this would become 6 over 6 plus 1/6 n minus 1/6. Okay, and so that would give us an nth term of 6 over 6 minus 1/6 is 5/6. So we get 1/6 n plus 5/6. Okay, so there's our nth term. All right, so in fact, the next page I have here asks you to take that one, to find the 15th term. So we want to find, so our nth term in that last one we just did was 1/6 n plus 5/6. So we want the 15th term. So I'm going to plug in 15. How do you want to do this? I picked an ugly one. Truthfully, these problems are simple. You're adding, you're multiplying, you're subtracting. That's really all you're doing here. I made this as complicated as it possibly could be here because it's fractions. So remember, this would be 15 over 1. So this would be 15/6 plus 5/6. I wouldn't bother reducing 15/6. I would just add it right now. And we get 20. Oops. Sorry about that. My screen just shut off there, the page I was writing on. All right, so what did we get there? In fact, it didn't even save everything I had. We had 20 over 6 plus, or sorry, 15 over 6 plus 5 over 6. And that's going to give me 20 over 6, but we need to reduce that. So the 15th term is, what is that, 10/3. Okay, and again, this is as ugly as it can get just because of the fractions. All right, that's the pretty easy stuff. I got two more examples here, and the first one I'm gonna kind of walk you through. And what's gonna happen with these examples? Instead of me giving you, the first 5 terms, I'm gonna give you 2 terms, and you've got to figure out the nth term. So there's a little bit of work. So I'm gonna go through the first one and kind of show you why and how, and then we're gonna come up with a quick and kind of clean, dirty way to get the answer, okay? Clean, dirty way? I just realized that doesn't make any sense. Clean way to get the answer. All right, so let's look at this here. It says the 8th term of an arithmetic sequence is 25. So a sub 8 is 25. And then it also says the 12th term, a sub 12, is 41. We want to find the first 5 terms and the nth term. All right. Well, remember, to find the nth term, this is our formula. We need to know 2 things. We need to know A1 and we need to know D. Okay? So the first thing we're going to find actually is D. I'm going to show you how to do that. So let's take this kind of little steps here, and like I said, we'll cut to the chase and show you how to do the next problem without all of this work. So the 12th term, if I were to use, my nth term formula, is equal to A1 plus, and that would be 12 minus 1D. I don't know what the D is. And I do know that equals 41. Okay. And then, let's see, we'll write it here. On one side of here. The 8th term, I can say the same thing. A sub 1 plus 8 minus 1 equals 25. Oops, I skipped something here. We need to have a D after the 8 minus 1. Okay, so I'm going to clean this up a little bit. So this one here, the first one, becomes this. A sub 1 plus 11D equals 41. Okay, and then I'm going to write right underneath this one, A sub 1 plus 7D equals 25. Okay, so now you got to go back in your Algebra 2 days. Basically what we have here is 2 equations with 2 variables, a systems of equations. But it's a really simple one. It's always the same thing. What do I want you to do? And I wrote this in a certain way. I wrote the higher term. This is the 12th term, and then the lower term, 8th term. I wrote them in order. Oops, I lost some stuff here. 41. And so I put the higher term first. What we're going to do is we're going to subtract. We're going to subtract these. Okay, so if you're going to subtract these, what's going to happen to the A1s? They're going to cancel, and then you're going to minus and minus. So we get 4D equals 16. So D is 4. Okay, but let's kind of cut, because this is where the work is. The rest of this is kind of easy plugging in and solving. What I need you to do is basically, we get this number in front of here by subtracting the term minus 1. All right, and we have the 41 over there, and then we do the same thing for the 8 and get 7. We just subtract the numbers in front, and we subtract what the terms are, and then we divide by that. Okay. All right, so try to follow that, use that, and we're going to do another examples. We'll see. But I still need to know what A1 is. Well, how do I find that? Well, I just use one of these formulas up here that I have, and it doesn't matter which one, right? And what do I know? I know A1 plus 7. Well, now we know what D is. It's 4 equals 25. So we should be able to figure out what A sub 1 is. Okay, so A sub 1 is -3. So then that means my nth term is -3 plus n minus 1 times 4. Distribute so we can get it simplified a little bit. All right, and so my nth term is going to be 4n, n minus 7. Okay. All right. Again, I could have plugged in over here. If I'd have done that, I would have had a1 plus 11 times 4, which is 44. Subtract, you still get -3. All right. So I'm going to do the next problem. It's very similar. We're going to try to cut to the chase. Okay. All right. So we have find only the nth term of the fifth term is 19. So we got a sub 5 is 19, and then the ninth term is 27. Okay, so really all I need is this, because the a1, if you want, you can write it out. You could say a1 plus, and 1 less is 8d equals 27, and then this one would be a1 plus, and this will be 4d equals 19. But here's the thing, I don't even need this. They're going to cancel every time. So really that's all I need to write. Okay? And then subtract. So I get 4d equals 8 and d equals 2. Now remember, d can be a negative, so you could get a negative on that. All right. Okay, now we have to figure out a1. To do that, we're going to use our formula. Okay, and one of these terms, I'm going to use the ninth term. So we're going to say a sub 9, we're going to say a sub 1 plus, and then this will be 9 minus 1 times 2, and that equals 27. So we don't have to really use this part. So we're going to say a sub 1 plus, and this is what, 8 times 2. So that's going to be 16 is 27. Okay. Did I do that right? I think so. Okay, so we get a sub 1, I was just checking my work, is 11. All right. Okay, we could have used fifth term, it doesn't matter. So then what does our nth term look like? Well, it's going to look like this. 11 plus n minus 1 times 2. Little distribution. 11 plus 2n minus 2. Okay, and so then my nth term is going to be 2n plus 9. Okay, one thing you can do is you can kind of check your formula out. If I were to plug in here, it's a sub 5. If I plug in a 5, do I get 19? Yeah, 2 times 5, that is 19. Okay, so it does work out. All right, so try out some of the problems here. I'm giving you some book work along with the answers there like normal in this next section. All right, take care.